All right, I know a lot of you had questions about finding area of composite figures. So first, let's quickly talk about what a composite figure is. Right here, we have a composite figure. It's basically just a figure or a shape that can be divided into more than one basic figures. So this composite figure can be broken into two rectangles. If I put a line right here, now I have two rectangles. So in order to find the area of this shape, all I have to do is find the area of both those rectangles and then add them together to find the total area. Okay, I'm going to get a different color. Let's try red, and we're going to do the top first. So here I have 2, and here I have 6. And I know that area equals length times width. So here's my length and here's my width. So all I have to do is fill in what I know. Area, I don't know the area. That's what I'm looking for. That's the unknown. But I know my length and I know my width, don't I? Okay, so I'm going to do 2 times 6. 2 right here, 6 times here. Area equals 2 times 6 is, what's 6 doubled? 12. Okay, so right here, my area is 12 square centimeters. Now the bottom rectangle, we just got to do the same thing. Let me get a different color for the bottom rectangle. Area equals length times width. Okay, so I have 5 centimeters and 9 centimeters. Area equals 5 times 9. I know my 9s. So area equals 45. 45 what? 45 square centimeters. Now I know the area of both of these rectangles. So to find the area of the entire composite shape, I have to add those two numbers together. 45 plus 12. 5 plus 2 is 7, 4 plus 1 is 5. So my total answer altogether is 57. 57 what? 57 square centimeters is my answer for my total composite shape. Okay, I'm going to check my answer. Now over here, 57 is correct. 57 square centimeters. Okay, this problem looks like it might be a little harder, but I have a little trick to show you about this problem. So this is basically, couldn't you see it? It's basically just a rectangle. And I know how to find the area of a rectangle. If I can find the area of this big rectangle, and then I can find the area of this little piece that got bitten out of it, then I could just take the total area of my rectangle and just subtract this part that was eaten. Like if we say it's a big cake and this much got eaten, then we could take the total area and just subtract the part that isn't there anymore. And we would end up with what we're looking for, which is the part that's shaded in this tan color, which is what we're looking for, okay? So that's what I'm going to do for this one, because I think that's a lot simpler than just trying to break this into rectangles. So first of all, I'm going to find the area of this big rectangle if everything was filled in. So I have that in this kind of teal color. I'm going to try to solve that best I can. So we have 12 feet this way and 10 feet this way. Area equals length times width. So the area of this big rectangle equals 12 times 10. Where did I get those numbers? Right here and right here. Okay, you always need two sides. Not this side and this side. It has to be two sides that are like this, length and width. Okay, so now we just need to do 12 times 10. Well, I know that 12 times 10 equals 120. So that means the area of the whole figure is 120 square feet. Now I just need to figure out the part that's this little bit that already got taken out of this figure. So I can see now that they're telling me that right here is 4 feet and right here is 5 feet. So area equals length times width. Area equals, what are my two numbers that I just found? 5 and 4. 5 times 4. Area equals 20 square feet. So now I know my total of the whole thing, if everything was filled in, would be 120. But everything is not filled in. There's 20 square feet that is not there. So since there's not 20 square feet, we have to take that away from what we found the total to be. So 120 minus 20. 0 minus 0 is 0. 2 minus 2 is 0. 1 minus 0, nothing, is 1. So my total answer would be 100 square feet. That is the part that is shaded in. Let's check our work over here. 100 is correct. Okay? And they described it the same way that I just did. Sample answer. I found the area of the larger rectangle by multiplying 10 times 12. Then I found the area of the missing piece by multiplying 4 times 5. I subtracted the area of the missing piece from the area of the larger rectangle. So sometimes that's just a quicker way to solve these kind of problems. So if you see one like that, where you see like a piece taken out, you can try to do it that way. Okay, now here's an example with a word problem. Shrubs, trees, flowers, and plants can be bought at Mr. Corley's nursery. What is the area of the nursery's garden at the right? Okay, so for this one, we could do either of the methods that we've learned, but I'm going to break it up into two different rectangles. I'm going to cut it right here, make that a little bigger. I'm going to cut it right here. I have two rectangles now. I have 8 yards by 10 yards, 8 yards by 10 yards, and I have 8 yards by 12 yards. So I don't need to find any missing parts because I already have what I need to know. 8 by 10 is 80. 8 by 12 is 96. So now I know both of those two parts and I just need to add them together. So 96 plus 80. This is where it really comes in handy, you guys, to know your times tables. Clearly, I knew those by heart, so I was able to do that, and I don't have to try doing repeated addition. I don't need a calculator. I don't need to solve any other way because I just know them by heart. 6 plus 0 is 6. 9 plus 8 is 17. So my answer is 176. 176 what? Square yards. YD stands for yards. Okay, so 176 square yards. Let me try to find the answer and see if I'm correct. And there it is. 80 plus 96 equals 176. So the area of the composite figure is 176 square yards. Okay, so here's an example where we are going to have to find what these missing sides are right here. So first thing I'm going to do is I'm going to break this into two. So I have two rectangles. Of course, I need to find the area of both rectangles and then add them together to find the total area of this shape. The problem with this little rectangle right here is that I only know one side. I only know the 3 centimeter side, but I don't know what the top or the bottom is. And I can't find the area if I only know one side. So how do we do that? How do we do that? Okay, well, I see that this side, I'm going to get a different color. I see that this side right here is part of a larger side. This whole part that I'm coloring green is 7 centimeters, right? And this right here is part of the 7 centimeters. It's part of it, but it's not 7 centimeters because it's only just a part of it. So if I'm going to try to figure out what that could be, I'm going to show you. Well, I know that when I have a rectangle, for example, if this were 3 by 5, I always know that if it is truly a rectangle, then the opposite sides are the same. We learned that. So the opposite side over here would be 3, and then the bottom would have to be 5, because opposite sides are the same. Okay, that's the definition of a rectangle. So watch this now. If I know that opposite sides are the same in a rectangle, then I can show you how we can solve this problem. So if we have 7 centimeters on the top of our rectangle, then let's pretend that this part right here did extend out. It doesn't, but if it did, then this would also equal 7 centimeters, okay, because top and bottom of the rectangle would be the same. So I would have it like something like this. 7 here, then let's pretend that this extends, then this would be 7 as well. And I know that this part is 4. So if this part is 4, then what we need to find is just this part, because this part would be the same here, here, and here, because same thing here, opposite sides are the same, because this is kind of like a rectangle too. So all we need to do is find 4 plus what equals 7. 4 plus what equals 7? 4 plus 3 equals 7. So if this right here is 3, then that also means that this right here is 3. And finally, right, what we're looking for is this right here must also be 3. So that means this section right here is 4, this section right here is 3, and we know it's right because 4 plus 3 does equal the total, the green, the 7 centimeters. 4 centimeters plus 3 centimeters does equal that 7 centimeters. So now we have, sorry, this is all getting a little messy. I'm going to move that away. Now we have to figure out the area of this. So now we know that it's 3 by 3 by 3 by 3, which means it's a square. It's a square, and each side is 3. But all we need to know is 2. We need to know the length and the width. So 3 times 3 is 9. So that means the area of this small square right here is 9 square centimeters. Then we just have to find out the area of this larger rectangle. Now, luckily, we don't have to find any missing sides because I see on the bottom it says it is 4 centimeters right here, and along the side is 5 centimeters. So I have everything I need to know to find the area of this blue rectangle. I have 5 times 4 because I have length times width. 5 times 4 equals 20. So now I have found that this right here is 20 square centimeters and this small square is 9 square centimeters. So to find the area of the composite shape, both of them together, I just have to do 20 plus 9, which equals, of course, 29. So the area of this shape is 29 square centimeters.